So Thursday, you're going to have your second Trig quiz. And then we only have a couple lessons to do after that. So next week, probably on Wednesday, will be your Trig test. And then that'll be it as far as uh, the course itself. There is one other chapter on puzzles and games. So maybe after Christmas, we might spend a few days on that. And it's just basically I give you a sheet of paper, and there's some websites that you can go to play some games that deal with mathematics. Okay, but then the rest of the time we'll be getting ready for your final exam. So I've got a bunch of review material we're going to go through, and some review assignments that you'll do to get ready for the final exam. Right. So um, before the end of December, before we leave for Christmas break, should have the final exam schedule available so that you guys can start planning for that. There's a pretty good chance you'll be writing your final exam earlier. The way it's been working the last few years is that there's just whatever day they start on, block one, final exams. If you have a block one class with a final exam, you write it on that day. And then the next day, the block two's write, and so on. But I'm gone for a week in January for marking diploma exams. So usually I'm gone during exam week. So that means that we'll just be writing our final exam a little bit early, which means that on during exam week, when it's the day for block two to write their final exams, you guys will have a day off. You won't have to come. Yes, sir. For the exam, if you hit 75 or greater. Yep. So 75 or greater, you don't have to write the final exam. Yes, sir. Off my desk. But also remember, you guys need to be on Power School. And if you see any missing marks for any of your assignments, you need to get those done and handed in. So there's going to be a dead date for those, probably a week or so before your final exam, um, so that I have time to get everything marked and put into Power School. But after that point, anything that you haven't handed in that was collected for marks will go in as a 0, and your mark will drop. So if you're sitting at 75, let's say right now, but you have a bunch of assignments not handed in, your mark will not stay 75. Right? So it'd be a good idea to start looking back at Power School now and seeing what you're missing. And if you need copies of those assignments, you let me know so I can get them for you. So you have time to get them done before they're no longer going to be accepted. Okay, so today we're going to spend some time looking at some more problems using our sine, cosine, and tangent. So this is on page 21 in your package. So this first question says that, well, first at the top, we've got our 3 trig ratios. And remember that SOHCAHTOA is something that we can use to help us remember what those ratios are. The SO part tells us that sine is opposite over hypotenuse. The CA part tells us that cosine is adjacent over hypotenuse. And the TOA part tells us that tangent is opposite over adjacent. Now for your test, you'll be given the trig ratios. You don't have to memorize them, right? But you just got to know how to use them. So example 1 says that Jana Lee is a cartographer. She is creating a map of a new housing development. She needs to include the angles at each intersection on the map. She knows the lengths of Seaway and Sunnyside Street. It says calculate the angle between the two streets to the nearest degree. So you can see the diagram is labeled there for us. The first thing we always do once we have the diagram is label the sides, right? We're trying to find the angle between the two streets, which would be that angle right there. So we can call it theta if we want, or you can label it with a letter, A, B, C, it doesn't matter. But you have to know, what are you trying to find? In this case, you're trying to find the angle between the two streets. So that's that angle there. Then we label the sides of the triangle, the right angle. right? That's the 90-degree angle. And often you'll see that little box symbol put in there, which tells you that that is the 90-degree angle. And that's important because the side across from that is the hypotenuse. We want to find this angle theta up here, so the side across from that is the opposite. You label the side across from the angle that you're using, or in this case, trying to find, as the opposite. And then the third side is the adjacent side. So that's always step one, once you have your diagram. Step two, which two sides are you going to use? In this case, you're given the adjacent and you're given the hypotenuse. Those are the two sides we're going to use. And so you need to look above and see which ratio uses the adjacent and the hypotenuse. Which one, Tyson? Cosine, that's right. Only cosine uses adjacent and hypotenuse. So now you're going to write your equation. The cosine of the angle, which in this case, that's what we're trying to find. The cosine of theta equals, and the order matters. The ka part tells us that it's adjacent first, hypotenuse second. Adjacent on top, so that's 1600, hypotenuse on the bottom. That's 3500. They must be in this order. And remember, if you want to find the angle, in this case, that's what we're trying to do. We're trying to find the angle. But you have the two sides, the ratio on the other side, the 1600 and the 3500. So if you want to find the angle, you go second function cosine of 1600 over 3500. So in your calculator, you want to do cos to the negative 1 of 1600 over 3500. That'll tell you what theta is. That'll tell you the angle theta such that the cosine of that angle is equivalent to 1600 over 35 as a ratio. So again, make sure that you're in degree mode. So you have to always make sure that you're in degree mode. And then go second function cosine of 1600 over 3500. And to the nearest degree, you'd round that to 63 degrees, right? The number in the 1 position is a 2. To the right of that is a 7, which means a 2 has to go up to a 3. So that's the angle between those two streets, 63 degrees. All right? Example 2, this one we have to draw the diagram for. It says a guy wire supports a cell tower. The guy wire that is supporting a cell tower is 24 meters long. If the wire is attached to the, or at a height of 17 meters up the tower, determine the angle that the guy wire makes with the ground. So if you don't have the diagram given, you can always start by drawing a right triangle. You must have a right triangle in order to use SOHCAHTOA. So that's what I'll start with. I start with drawing a right triangle. So if you drive around in the country and you see towers, most of them have guy wires. So it's a wire that is connected, and it's not always at the top of the tower. It doesn't have to be. It doesn't have to be at the top of the tower. But what these guy wires do is they support the tower so that if in case there's any winds, usually, that are blowing, then the tower is supported. It's not going to fall over because of the wind. So they are attached, these wires, at some point to the tower. Sometimes they're at the very top, sometimes they're part way down, and then they're anchored into the ground, usually by concrete. And usually there's more than one of them. Okay, depending on where the prevailing winds are from, there might be one on the left side and the right side, or there might be 4 of them on there to cover against the wind no matter what direction it's coming from. But that's what a guy wire is. So in this case here, we are told that the guy wire is 24 meters long. That's how long the wire is. It's attached from the tower to the ground. And then it's attached at a height of 17 meters up the tower. So that's the height there. And again, you must have a right angle here, because otherwise you can't use SOHCAHTOA and you can't use Pythagorean theorem. This question says, determine the angle that the wire makes with the ground, forms with the ground. So it's the angle between the wire and the ground. It's that angle down there at the bottom left-hand corner. So now that we have our diagram, we label the sides. The side across from the right angle is the hypotenuse. You're trying to find the angle theta. The side across from that is the opposite. Third side is the adjacent side. So that's how we would label the sides of the triangle. Which two sides are we using here, Mason? Because those are the two sides that we're given. That's right. We must use the opposite and the hypotenuse here. We're not given the adjacent, not asked to find it. So Thomas, which ratio uses opposite and hypotenuse? You got sin on your brain? Yeah. Sine, but yeah. Well, you're a sinner, I guess, so you can use sin if you want. Me, on the other hand, I say sine because I'm not a sinner. That's right. So what will the rest of it look like? Well, let's write our equation first. The sine of theta equals, what will the other side look like? What would you write? Is that right, Brandy? Yes. It must be O first, H second. The so part tells us that. Opposite on top, hypotenuse on the bottom. If you flip them around and then go sine to the -1, if you flip them around, you'll get an error. I've said this before, that the sine and cosine of every angle will be a decimal between 0 and 1. If the 24 is on top and 17 on the bottom, because the bigger number is on top, you'll get a decimal greater than 1. Won't work. You'll get an error. So, second function, sine of 17 on 24. So if you run that to the nearest degree, that would be 45 degrees. The digit to the right of the 5 is a 0, which means the 5 stays the same. So that wire makes an angle of 45 degrees with the ground. So this next example is similar. A radio transmission tower is to be supported by a guy wire. So let's start by drawing a right triangle. You always need a right triangle in order to use SOHCAHTOA or Pythagorean theorem. So you might as well start. And again, the guy wire might go to the very top of the tower, or it might go part way up. It doesn't matter. Unless you're told specifically, it doesn't matter. But in this case, we are told that the guy wire reaches 30 meters up the tower. So that's that side there. And is attached to the ground a horizontal distance of 14 feet from the base of the tower. So the distance from where the wire is attached, which is to the ground, which is at that bottom left-hand corner, to the base of the tower is 14 meters. So in this case here, that's the bottom of the triangle. Once again, the question wants to know what angle the wire forms with the ground. So it's the angle at the bottom left, where the wire meets the ground. That's the angle we're looking for. So now that we have our diagram, our next step is to label the sides. The side across from the right angle is the hypotenuse. The side across from the angle that we're looking for is the opposite. The third side is the adjacent side. Which two sides will we use here, Jet? Which uses what ratio? The tangent. Yep, because only tangent uses those two sides. So what will our equation look like, Brandy? Tan of theta equals what? So that's okay. You agree with what she has there so far, Jamie? Do you agree with what she has so far there? Yes, because tangent is opposite over adjacent. Now, 30 over 14 is going to be a decimal greater than 1, but that's okay because this is tangent. It's only sine and cos that it won't work. So yes, to find theta, we have to go tan to the negative 1 of 30 over 14. So second function, tan of 30 over 14. So to the nearest degree, you're looking at the 4 and the digit to the right. Because the digit to the right of the 4 is a 9, the 4 has to go up to a 5. So theta will be, in this case, 65 degrees. That's the angle that the guy wire makes with the ground. Okay? So we're going to stop there. And again, on Thursday, there's going to be a quiz on trig, and then probably next Wednesday will be our test on trig. Okay? So I will hand out the assignment.